So today we are going to see the concept of stack. It's very interesting, and even though we programmatically also we are going to understood like how exactly that we are going to implement. So whenever we see the stack, or whenever we ask about the stack, or we heard about the stacks, comes into the picture. There are something which are stored one after another. Okay. So if you try to visualize this concept, you will try to draw that diagram. So just consider that it is our stack, and we are storing a data like one after another. So that means the first data is my storing here. So let's me create some stack here first. This is my first block, second block, third block, and this is fourth block, right? And I'm want to store some data here. So let's me add some data and just try to write here, suppose a zeroth position of it. Then for the second one, I'm right. This is what first positions. Like after zero, one is stored. Then I'm storing as a two here, right? And after that, I will store three. How I'm storing data? One after another. One after right? So let me use some different color. So it will be look good. Some third. Fine. Now, if I want to store a fourth element, where should I store? In above three, right? Because it is not possible to me like I can store a data in between or at the beginning. Okay. So the stack basically work. That is in short, there is a standard word for the stack. Is that is nothing but LIFO. LIFO. The LIFO stand for last in, LAST, last in, first out. Okay, what do you mean by LIFO? The LIFO stand for last in, the first out. Just imagine if I want to store a data as a fourth here, so I can add a fourth. But now, though I try to remove three, but it's not possible to remove three directly because which one is the element which is come last? Fourth one. So if I want to try to remove, then which concept is get removed? Fourth one. Why it is? Because it is coming last and removing first. Okay. So that means it's work in the standard of last in, first out. Okay. So this is a concept of stack. Whichever is thing that you done at last, that is going to remove first. Okay. Getting something like why stack? The stack is provide such a structure where we use this kind of concept. So now let me quickly give one real-time example so you can able to connect. Oh, this is an area where the stack is used. The best example of using stack or is nothing but our undo operation. Okay, undo operation is a best example of what stack. So let's see the undo is an example of stack. So you may consider how it is example. So let clarify it. So just observe now I am drawing one circle here. Which circle I'm drawing? Color is what? Black, right? After the black circle, I'm drawing circle as a red. Perfect. And after this, I will draw the circle as blue. Then after that, I'm going to draw the circle as this. So now, which circle we have drawn first? After that, red, blue, and then this. violets. But if I do undo control Z, which one is get removed first? Latest one, see this. After that, though I try to remove the red one, but red one is not removed. Which one is removed? Blue, red, then black. Okay. Then you understood where the stack is used, in which area and why it is used. So in kind of undo operation, the best example of a stack. And it is a necessary also. Imagine that you have written 1000 line of code. Just imagine. Okay. Suppose now this is my anything you can get that some kind of code is there. So assume that this is some basic 30 lines of code. And I am writing something here like in ABC, and after that something. So though I did a mistake in NZ, so I'm going to control Z, NZ only, no? Then only it is a useful. Otherwise, you are writing a 3000s of line of code and you are making mistake in line number 2998. But there is somewhere at undo operation is happening. So that will be create a big problems. So the stack will be the useful because it only undo the things whichever the things you have done at very last. So that also we can connect. Okay, this is the things I'm writing, and this is only unchecked. Like this first, then this, right? So such a area we need some special memory which provides such a structure so that we can store data one after another, and the things will be get removed whichever they come last, which is get removed first. And that is a concept of a stack. Okay, you got the concept why we need a stack. And the best example is undo operation. Okay, yeah. Now we'll go with a technicality. Then, which method is used for adding data? Which method is used for removing data? And how we can add data and how we can remove it. Okay, so whenever you want to add data, okay, so let's make you some for, you can see that simply this thing else you can take for adding data. So this the way where we can add a data. For adding data, there is a function that is known as a push, push. Okay, if you want to add some data, you can use push method. Up to now in a list and array list, which method we used for adding data? How we are storing a data in a list or array list, linked list or array list? Which method we have used for storing data? Yesterday only we did the program, na? How we are adding data in a list, array list? Which method we used to store a data? Hello, add method we use, no? But in stack, exactly. And for removing, which method we use? Remove itself. But in stack, for adding data, what we are using? Push. And if you exactly, and if you want to some remove data from the stack, so like inside removing data. So for removing data, there is a function called pop, pop. Okay. So let me comment this also like remove data. And here the push means add. Okay. Let me write here so that you'll understood add. So two operation we are seeing. While adding, you can use a push method. While removing, you can remove pop methods. And there is a one more method known as a pick. Okay. So let me take some different color here. Pick methods. Then the pick is method P double E K pick methods. So what is use of pick? So basically pick point to last data. Okay. It is just using for pointing last data. Got it? Then there is oh no, it is only for the last, whichever the current value at the top. Okay, this is the purpose, because we are keep on removing. If you want to check what value we are going to remove the next, so pick will be point to the last points. So this will be the value the next. Do you want to remove or not? Means while you can make any use of that pick methods. So now this is a general methods that we are going to use, because program is very simple. Okay, not that much complicated. We can just create the object of stack, as we already created the object of array list and the linked list. For adding data we are using a push method, and for removing data we can use the pop methods. Okay, so these are the only two ways which are available in a stack. Okay, it is not like an array list or a linked list which will provide to add data at any positions. You can even the add data at last, even you can data at first, even we can add data in between, right? That feature, if you want that kind of feature, then go with the linked list. Okay, so depending on your need, you can use the stories. In the similar manner, real time exam, in real time also, the depending on situation or depending on things, we are using the stories. Like if you want to store some water, so you always try to find some bottle kind of things so that water will be best fitted for this, right? In the similar manner, you see, depend on situation, which collection things or which collection class should we use so that it will be better fit. So every collection or every Java collection class have a different feature. Based on our need, we can select and we can use it. Okay. So now let's implement the stack concept practically. As usual, the very first thing what we are going to do, and also we can practically observe also. So the things that we have written exactly same, it is working also or not. Okay. So let's go the simply here, and as usual, just right click here, create the main class. So let me give the main class as a stack demo. This is our main class. Okay, fine. In a very simple manner, the whichever the things we want to implement, first of all, what you're going to do, we're going to create the class object. What we are using now, stack, stack stack, right? Stack, stack stack. The type we are going to pass in. Even you can pass the integer, a float, string, anything. It is not always about an integer only. So the based on your need, you can like, let me add as a string. So it is also possible. Okay. But the based on the type you pass, that value you need to only insert. Right. So S is equal to new stack. Fine. So this is the very first thing that we need to do. Stack. Perfect. So let me battery is down. 1 second, just me add battery. Now let's add the data. For adding data, which function provide the stack. For adding data, what we are using? Push method, na? Push is the method. So let's me add here data s dot push. So let me push, suppose here A. Let me some randomly add, suppose here D. Then after that, let me add here s dot push. Suppose let me add here A. Okay. So if I keep on adding data, s dot push. So let me add here, suppose h, and now s dot push. Suppose I'm adding here C. Now tell me what will be the structure of this stack. Can you imagine how it is storing a data? Can you able to try to imagine? So we have created one stack and also we are adding a data. So for seeing this code, can you able to imagine the structure of this? What structure is generated in background? So basically, whenever we are creating a stack, that means this stack is generated, right? So the very first data, which one is stored now? How this stack is generated? The first one is stored at D, right? After that D, we have A, and then after that we have H, and after that we have C, right? So this is a structure which is generated in the stack. Though if I run this program, you will come to know same structure is generated at background. Sorry, we have not saved this program. So let me save this first. Right click, run as Java application, right? Now see the same things. First is a D, then A, H, and the C. Okay. So the things that we have drawn is exactly working same. Now let's check other functions also. So the let's check the pick function. Okay, s dot pick. What we understood about a pick? What pick function do? It's point to the last data. And what is the last data in a stack? Which data we have last in stack? Hello. What is our last data in stack? Hello, are you there? Hello. So in the stack, hello. Yes, sir. Okay, can you see the screen No, sir. now? Okay, let me present. You get got disconnect. Okay. Okay. So we are trying to implementing a stack. So if you see the code from that, you'll come to know how the structure is generated background. So in background, the structure is generated like this. First of all, D is stored, then A, then H, then C. Okay. And the first function I'm using here, like pick. What is the use of pick function here? Now, which one is the last data we have now? C. It points to the C, right? So let's, if I run these programs, you come to know we'll get output as what? C. Perfect. Same thing is working. And even though you are observed the like or stack, first one is what? D, then A, then H, and then Z. Why this so? Because we are adding data in like this manner. This. Perfect. And if I add one more data here, like S dot push method, right? Suppose I'm adding here a Z1. So where the Z is get added? After C only, because it's storing at the data last. We are not save this program. Let me save this now. Z is at last. Perfect. Up to the same thing is working. Now just imagine I'm trying to remove data. How we can remove the data from the stack? Which method you are using removing stack? Pop method. So I can write s dot pop here. So after popping, what data or what stack we can have here? Now, which data get removed if I do the pop? I'm not passing any index and not doing anything. Huh? I'm just writing push method, pick method, and pop method. The pop method will be remove data. Then which data is get removed first? Because our structure is LIFO, whichever the last comes, which is come first. If I do one more time pop, then C is get removed. C is get removed. If I do one more pop, H is. Exactly the same thing is happening, whichever we have done diagrammatically. We can able to generate the stack which store data one after another. And then we are for adding data using a push method. For removing data, we are using a pop methods. And for pointing data last, we are using a pick method. Everything is properly working. So this is a way of using a stack and all that things. Now the question comes, what if I want to print all the stack data, right? How I can print all the stack data? Is there any way where we can print or where we can access all the stack data? Because now see, it is not an index base. Only operation is happening at one end. Either it is adding or removing. And pick is a function where which we can get the last element. And there is a one function called a size. Size is a function where we can get the stack size. Right? So stack size is 3. Now, what if I want to print all the data? So let's me use some for loop here. For integer I is equal to 0, integer I is equal to 0, semicolon I less than what? S dot size, semicolon I plus plus. Right? But I don't know how exactly it works. Let me just try. So what we are trying to do. So let me do s dot pick. So is there anything we'll do, or it may happen that it will keep on pointing the last data, that is h 3 times, and exactly same thing is happen, right? So now, but how we can print all the data? That is the question. The pick is point last data, right? So we are not any, you are finding any way where we can print all the data. Just think quite, because this is all about this. How? Yes, everyone. Okay, it's used mean to say that we are removing printing. Okay, so that means first we need to point, then remove, point, then remove, right? So even though means simultaneously we have to do the s dot pop also. Okay, let's try the solutions and ERR. But the problem is, okay, it will work at something, but at the end, only one thing we'll get, that is E. But I want to print all the data. Wait, then how? How? Okay, let me. No, there is not a built-in function. Give me some hint. You can use anything. You can make a use of list also. You can combine anything for storing data and all that things. That you can do. Now can tell me like, is there anything we can find? Is there any way? So just print this in SYSO, right? S dot pop. We have printed all the data. Yes, we got all the things, no, right? Or not? Let's errors. Which one we have? Only we have H and A. We have H and A. Why you are not getting D here? Why not D? Okay, less than equal to. Let me write here. So now we can have only two data we are printing. Why this so? Because if we see there, we have a three data D, A, and H. So it is printing S dot pop. So at the last is H. It is printing H. Then we having S dot pop. Then we having A. So it is printing A. Then after that, D is also there, right? So why it is not printing D here now? Okay, so now basically that means the size is not working here. It is protecting the last data. So then there is a one more functions. So let's try this. So we can go for the while loops, and you know the while is printing until the last condition. So will yes. So there is a function while s dot is empty is empty. So I'm writing not empty means until the stack is not empty. Okay, print all the data. Got it? So now let's try now here. So now we are. So size is what exactly doing? It's trying to protect one last data. So it is not making a stack empty. It's skipping one data. So the best way what we are used, there is a one function called as an is empty. Until the stack become empty, print all the data. Means keep on printing pop, pop, pop. So we are writing it H, A, and the D. Right? So this is a thing all about the stack. It's a simple and the sweet main understand this concept. This is a structure, push function for adding, pop function for removing, pick pointer for uh, lasting point data. And there one more things we have, that is the size is for getting size of data. Size, SIZD, right? Size function. Get the total size. And then we have one more thing, is empty method for checking is empty. So these are the only thing which is available in stack. Understood this? Okay. So now this is all about a stack concept.